Welcome back to another episode of Principles of Microeconomics. We learned about market structures in the previous episode. Now we're going to look at monopolistic competition in the short run. So remember we said that monopolistically competitive firms have market power, that is the ability to influence price. Unlike the perfectly competitive firms are price takers and they have no ability to influence price. Now, unlike a monopoly though, the monopolistically competitive firm has a lot of competition from similar products. That's going to cause the demand curve for the firm to be elastic. So let me refresh your memories on what the difference is between elastic and inelastic. Elastic demand is demand that is very sensitive to changes in price. So you can see here on our graph that a small decrease in price leads to a large increase in quantity. So price barely changed, but quantity had this huge, almost double looks like, on our graph. So this demand curve is very responsive to price. We call that elastic demand. On the other hand, there is inelastic demand, which means the demand curve is a lot steeper. Here, when you change price by a lot, there's not a huge response from quantity. So this is called inelastic. Now, if there are lots of similar firms out there with similar products, if you try to raise your price a lot, then people are going to leave your good and start going toward your competitors. Even if your good is a little bit special or unique in some way, and it's not quite identical to the other firms, if you try to make it a lot more expensive, people are just going to go for the competition, go for the substitute goods, which are similar if not quite the same. So, because demand is so sensitive to price, though the firm has influence over price, that influence is going to be pretty limited. They can't do monopolist pricing like charge $200 for a textbook. That's not possible in a monopolistically competitive market. So we're still the same profit maximizing rule as a monopolist, which is marginal revenue equals marginal cost. Now the perfect competition result, price equals marginal cost, does not apply here. So what we showed earlier is that the general profit maximizing rule for any kind of firm is marginal revenue equals marginal cost. In the special case of perfect competition, then price is equal to marginal revenue. Now, however, if you're in a monopolistically competitive market, if you want to sell more goods, you want to increase quantity, then you've got to change price. That's going to cause the price to be different from the firm's marginal revenue. So I can't plug in price equals marginal revenue into this rule here. That means that the result price equals marginal cost that I had earlier does not apply to this particular market. So here's a numerical example showing you guys that price does not equal marginal revenue in monopolistic competition. So here's price and quantity for demand. Let's say when price is 10, we're going to sell 1 unit. If we want to sell a second unit, we got to cut prices to 8. To sell unit number 3, prices go all the way down to 5. So you can calculate total revenue by taking price times quantity. 10 times 1 is 10, 8 times 2 is 16, 5 times 3 is 15. Once you've got that in place, you can calculate the marginal revenue by seeing how does total revenue change when you increase production. So we went from 1 to 2, that increased revenue by 6. So marginal revenue is going to be 6. If you increase production from 2 to 3, you had to cut prices from 8 to 5. That meant your total revenue had to fall from 16 to 15. So because total revenue fell by $1, your marginal revenue is negative 1. So if you go and compare the price column with our marginal revenue column, you can see they aren't the same thing. That's how I know you can't plug in price equals marginal revenue up here, so you don't get price equals marginal cost anymore. So the rule that applies to perfect competition does not apply to monopolistic competition. So you got to go back to MR equals MC. So here's the situation for perfect competition, just to show the comparison. We said that, well, the overall market has a downward sloping demand curve, or the law of demand. People buy more as goods get cheaper. If you're just one tiny firm in that giant marketplace, demand is going to look more like this. If you produce 0 or if you produce 8, the market price is still 5. So in perfect competition, price is going to be 5 no matter how much or how little you produce. Then here's how you calculate total revenue. You just take price times quantity. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. Next step, we'll have to change the total revenue. Going from 5 to 10, it's a change of 5, so MR is going to be 5. Going from 10 to 15 is also a change of 5. Therefore, MR is going to be 5 again. So in that case, MR and price are the same. So you plug into MR equals MC, the rule price equals marginal cost emerges for perfect competition. So you can see that's different from monopolistic competition. So though they follow the same rule as the monopolist does if you're in monopolistic competition, the result's going to look fairly different because, unlike a monopolist, demand is going to be much more elastic for the monopolistically competitive firm. Remember we said earlier in chapter 4, talk about elasticity. One of the determinants of elasticity is the availability of close substitutes. If you're a monopolist, you're the only seller, there are no substitutes. So demand is going to be fairly inelastic for a monopolist. It's going to be insensitive to price, so they can jack up the price a lot and charge you a ton of money for a textbook, and you have to accept it. There's no choice. If demand is instead very elastic, like demand for restaurants, there are many different restaurants out there that are selling you pretty similar food, though not quite identical, then your ability to raise prices is much more constrained. Here's another example that's more apples to apples. So with college textbooks, there's not a lot of close substitutes. There are a lot of econ textbooks out there, but only one is suitable for this particular class. So if you buy the book by Mankiw instead of buying the book by Kopek and Mateer, you're not going to be really prepared for this particular class. So not really a close substitute. So this class's textbook is really expensive, and they can get away with that. With mystery novels, though, there's a lot of different mystery novels out there that are pretty similar with their characters and the plot and all that. So if a mystery novel author try to jack up their price like a college textbook author does, they don't get away with it. People start buying from a different, though similar, mystery author instead. So when they follow the same rules of monopolists, the outcome's going to look pretty different. So here's a numerical problem for you guys to work through. I've given you the demand, the price and quantity in this market, and also the total cost. So what I want you guys to do is calculate total revenue and also find marginal revenue and marginal cost. Once you've completed all that, you can go and find the profit maximizing price and quantity, and also how much profit does the firm make. So go ahead and pause the video here until you work through the problem. Then you can unpause it and we'll go over the answer together. So stop the video right about now. Alright, I'm presuming you have finished the problem, so let's talk about the answer. So the first thing we can do is find total revenue. That's just price times quantity, our typical formula. 100 times 1 is 100. 98 times 2 comes out to 196. 95 times 3 is 285. And lastly, 90 times 4 is 360. So now I have the total revenue column in place. We can calculate marginal revenue. We can find how does total revenue change when you increase production. So you produce 1 unit, your total revenue was 100. When you produce 2, it was 196. That's an increase of $96. So marginal revenue is going to be 96 over here. So you follow the arrows, 100 plus 96 comes out to 196. Similarly, when you go from producing 2 units to 3 units, total revenue rises from 196 to 285. That's an increase of 89. So 196 plus 89 is 285. That's how I know marginal revenue in this cell of the table. Very last part for marginal revenue, if you go from producing 3 to producing 4, total revenue is going to rise by 75. 285 plus 75 is 360. So MR is going to be 75 down here. Next, we do the same thing for marginal cost. So you produced 1 unit, your total costs were 140. If you produce a second unit, it goes up to 236. That's an increase of $96. Therefore, MC is going to be 96. Likewise, if you go from producing 2 to producing 3, your costs go from 236 to 350. That's an increase of 114. Therefore, MC is going to be 114. 236 and 114 is 350. Very last cell in our table, if you go from making 3 units to making 4 units, your costs rise by 150, going from 350 to 500. So you put 150 down in the MC column over here. As noted earlier, if you're in monopolistic competition, price does not equal marginal revenue in general. So you compare these two columns here, you see the numbers don't match up. Alright, so you fill in our table. Now we got to figure out what is the profit maximizing price, what is profit maximizing quantity, and also how much profit does the firm make. So our profit maximizing rule is marginal revenue equals marginal cost. So you go through our table here, you can see in the second row, those things match up. So here in quantity is 2 and price is 98, MR equals MC. They're both at 96. So that tells us the firm should produce 2 units and it should sell it for a price of $98 each. So you can also calculate the firm's profit. Profit is always total revenue minus total costs. So at that production level, total revenue is 196. Total costs are 236. 196 minus 236 comes out to negative 40. So this firm is losing $40. Another question of interest is calculating the firm's markup. So under perfect competition, you charge price equals marginal cost, which means there is no markup. Now, if you're in a different environment, like a monopoly or in monopolistic competition, now a firm can charge a price that's above the marginal cost. And that extra charge they can do, the extra money they can make per good, is called the markup. So the gap between price and marginal cost. So at our profit maximizing quantity, the price is 98, but the marginal cost is 96. So the price we're charging is $2 higher than the marginal cost. That means our markup is going to be $2. Now you can note over here, even though we're charging a markup, a price above marginal cost, the firm can still make a loss anyways. So you're making profit on each additional good you're selling, but there might have been a very large fixed cost you're still trying to recover. I mean, that large fixed cost is not entirely recovered when you're producing 2 units. So the existence of a markup does not necessarily imply that the firm is making a profit. As you see over here, you have both a markup and a loss at the same time. So here's how you solve it graphically. So first step, you gotta find where is marginal revenue equal marginal cost. Hang on a moment, guys. My throat's a little bit dry here. Let me get some water. That's better. So you find where is marginal revenue equal marginal cost, and that's going to pin down what is the profit maximizing quantity. So in our graph over here, the demand curve is the green line. The marginal revenue line is the one down here in red. Now I told you this result earlier in chapter 10. Let us remind you of it. When you have a linear demand curve, and this one here is linear, so it meets our criteria. When demand is linear, the marginal revenue curve is the same intercept but double the slope. So that's how this line is constructed. The marginal cost line here is shown in orange, and then the average total cost is in blue. So where the red line meets the orange line, that's where marginal revenue equals marginal cost. So the firm should produce about 8 units. So the next step is to plot that quantity up on the demand curve. So first you find these two lines intersect, they just go up until you hit demand. Once you're on the demand curve, you just trace out the line to the left until you bump into the y-axis. That's going to tell you what the profit maximizing price is. So this firm's going to charge, looks like around $65 for each unit. So you can find the profit on the graph. So profit is going to be total revenue minus total cost. Another way of expressing that is your revenue per unit, that is the price, minus the cost per unit. You multiply all that by the quantity you're selling. That corresponds to this rectangle on our graph. So the price up here at 65 is your revenue per unit. That's how much money you make every time you sell a unit. But you pay a cost shown here by the average total cost curve. So look at where is that blue line at when you have that profit maximizing quantity. It's going to be somewhere down here. So an average when the firm sells a unit, they make this much money, but they have to pay a cost of that much in order to do so. The net result, they get the profit per unit is going to be that gap between those 2 points. So that's profit per unit. If you multiply it by a number of units, which is going here by where MR equals MC, then you have total profit. So we know how to do it both graphically and also through the table. We had that numerical example earlier. Let's work through another numerical example. So here, instead of showing you a table or a graph, I'm showing you a couple of equations. So demand is given by price equals 100 minus 3Q. And to keep things very simple, the marginal costs are just linear. MC is 4Q. Your mission is to find the profit maximizing price and quantity for this firm. I'll give you guys a little bit of a hint so you know that marginal revenue is going to be involved here. And I told you that result earlier where if demand is linear, and this demand curve is indeed linear, then MR is the same intercept, but double the slope. So with that hint, go ahead and work through the problem. Pause the video. When you're finished, come back and we'll look at the answer. Alright, I'm going to assume that you worked through the problem. Let's see what you got. So the intercept here is 100 on our demand curve. MR is the same intercept, so that was going to have an intercept of 100. The slope is going to be doubled. On demand, the slope is negative 3. If you double that, the slope is going to be negative 6. So in marginal revenue, the equation is going to be 100 minus 6Q. With that result in hand, you can now use our profit maximization rule, which is marginal revenue equals marginal cost. So you set 100 minus 6Q, MR, equal to 4Q, which is MC, and you can solve for Q. So we're showing that over here. So to solve that equation, you add the 6Q to both sides. That leaves you with 100 equals 10 times Q. To solve for Q, what you got to do next is divide both sides by 10. 100 over 10 is 10, so I'll say Q star is 10. It's pretty common notation in economics to show the star for optimal. So optimal, in this case, profit maximizing. So profit maximizing quantity is going to be 10 units. Now you know from before that once you have the profit maximizing quantity, you have to plug it into demand to find the profit maximizing price. We saw it earlier when we looked at the graphical analysis back over here. So first you find MR equals MC to find Q, and then you find where's that line in demand to find price. So let's do the analogous thing for the mathematical equations. So we're going to take Q equals 10 and plug it into our demand curve, which is 100 minus 3 times Q. So that becomes 100 minus 3 times 10. That's going to be 100 minus 30. 100 minus 30 comes out to 70. So our big result is a firm should charge a price of $70 and sell a quantity of 10 units. So now you know how to maximize profit in the short run. So we'll stop our episode here. Be sure to tune in for our next episode, and we'll learn about the long run.